Greetings, I'm Michael Quinn Patton. I did a video featuring Peter Rossi's Iron Law of Evaluation, and that got inquiries about what his other laws were, because the article on which that Iron Law was based was entitled The Iron Law of Evaluation and Other Metallic Rules. So folks have been asking me, what are the other metallic rules? This classic article, written by Peter Rossi in 1987, reflects his wit, his charismatic nature as a speaker, his humor, and his way of grasping key ideas and communicating them. Peter Rossi is the co-author of the major textbook in evaluation from that time, now in its 8th edition, and most widely used evaluation text perhaps in the world. So, the Iron Law of Evaluation, just to repeat, was the expected value of any net assessment of any large-scale social program is 0. So basically, Peter Rossi was arguing that large-scale programs basically don't work. Well, what are the other metallic laws? The stainless steel law of evaluation says, quote, the better designed the impact assessment of a social program, more likely is the resulting estimate of net impact to be 0. So it's really a further framing of the Iron Law. Specifically, this law implies that estimating net impacts through randomized control experiments, the avowedly best approach to estimating net impacts, is more likely to show 0 effects than other rigorous approaches. So he's saying the more rigorous the evaluation, the less likely it is to show any kind of positive results. The Brass Law of Evaluation, quote, the more social programs are designed to change individuals, the more likely the net impact of the program will be 0. The law is intended to emphasize the especially difficult task of designing and implementing effective programs that are designed to rehabilitate individuals. And finally, the Zinc Law of Evaluation. Only those programs that are likely to fail are evaluated. Rossi says, quote, of the several metallic laws of evaluation, the Zinc Law actually has the most optimistic slant, since it implies that there are effective programs, but that such effective programs are never evaluated. It also implies that if a social program is effective, that characteristic is obvious enough, and hence policymakers and others who sponsor and fund evaluations decide against evaluation. So we've got the Iron Law, the Stainless Steel Law, the Brass Law, and the Zinc Law. What are the implications of Rossi's metallic laws? Well, here's how I see them. First, they clearly aren't laws, and in the article himself, he notes that there's a lot of sponginess, that they're not universal, that he means them to grab attention. They are more metaphoric than real. They clearly are not laws. And secondly, they are based upon experimental design logic, the search for proven models with definitive average results that are scalable. That's what Rossi was looking for. He defined evaluation as the application of social science methods to determine if a program is effective. He was particularly interested in what he considered rigorous methods of experimental designs. And those designs were used to search for generalizable, scalable models that were proven to be effective. Major example that he refers to in the article was the project follow-through evaluation from 1967 to 1977, the most extensive educational experiment ever conducted, charged with determining the best way of teaching at-risk children from kindergarten through grade 3. 22 different models of instruction were compared. Over 200,000 children in 178 communities were part of the project follow-through evaluation. The communities that implemented the demographic approaches spanned a great range of demographic variables, by ethnicity, by economics of the communities. And the results showed that there were more variations within models than between models. No model emerged as overall best. So these overall findings of the Head Start of the project follow-through evaluation: greater variation within models than between them. The effectiveness of each follow-through model depended more on local circumstances than on the nature of the model. And you have to disaggregate the data to find and distinguish the success factors and effective practices in these kinds of experiments. It turns out that a major factor in the success of any given classroom was the relationship between the teacher and the student. And where those relationships were strong, regardless of the nature of the model, the results were more positive. Context mattered a great deal. The different context that the project follow-through was conducted in made a difference in what results were achieved. And so what this suggests to me is an implication for the iron laws and the other laws of Rossi is he is in the quest for the best way to do something. But what we've learned, it seems to me, in the last 50 years is to reframe the question. There aren't best practices. There's no single best way to do something. The question is, what works for whom, in what ways, with what results, in what context? That's a different question. It means you have to look inside the average data, and within that average data, there are successes, there are failures, there's a range of outcomes, and understand the variations in that range rather than simply the average result, which, as Rossi predicts, is typically 0, comparing the control and the treatment group. But within the treatment group, there is a range of responses, from more effective to less effective, from more successful to less successful. And understanding those gives us insights into factors around success, especially the way in which context matters, the way in which relationships matter. He also, in that article, refers to the New Jersey negative income tax experiment of the 60s and 70s, which was looking for the ways in which people would respond to economic incentives. That major experiment found no significant impact on labor force participation, on spending patterns, on quality of life indicators. But what it found was that people were thoughtful about how they spent money, and that they were conscious of the ways in which their levels of income affected the kind of decisions that they made. And so the overall implications, it seems to me, of the Rossi law, now the set of metallic laws, is that first, they aren't laws. Secondly, given that they are based on the experimental design logic, we need to replace that search for definitive effects that are scalable to ask what works in what situations with what results. And it's a reason for moving to systems transformation, as the field is doing, moving from simply trying to change individual behavior, which he found in his law was unlikely to be successful, to changing systems. And that is a major current direction in evaluation. And so we need to avoid cynicism that there are no successes. There are successes. You should know what works in your arena of expertise to help debunk the myth that nothing works. But it's true that large-scale, context-free, generalizable, scalable models don't work because context matters and relationships matters. So we move from Rossi's laws of evaluation to, let me offer 3 principles. Context matters, systems matter, relationships matter. And when we look at those things, we find patterns of success across different kinds of programs.